Welcome to The Explainer. Today, we're unpacking the fundamentals of the world's most talked about programming language, Python. Whether you're literally taking your very first steps into coding or you're just looking to understand how modern software actually works under the hood, you have absolutely felt Python's massive impact on our digital world.
But it really begs the question, why does one programming language dominate so completely? I mean, in a world packed with countless digital tools and wildly complex frameworks, how did this specific language become the absolute go-to choice for everything? From simple automated scripts to massive global tech infrastructures. Well, that's our journey today. We're going to completely demystify this. We'll break down exactly how Python pulls off this crazy balancing act, empowering someone on day one to start building, while still acting as the heavy-duty engine relied upon by the world's top software experts.
Okay, let's dive into this. Section 1, the origins of Python and building the foundation.
The whole story kicks off in this pivotal year right here, 1991. This is when the creator, Guido van Rossum, initially unleashed Python onto the world. And, he envisioned a popular, high-level language, but with a very specific, radically human-centric philosophy in mind. It wasn't just about what the computer could do to crunch numbers, it was about the actual human being sitting at the keyboard trying to solve a problem.
And that human-centric philosophy, it was a massive, real game changer. Think about it. Before Python, coding usually meant battling with incredibly dense, confusing syntax in older languages like C++ or Java, just to execute a basic command. Python flipped the script. It prioritized code readability above almost everything else, which enabled programmers to express really complex concepts in significantly fewer lines of code. It was a total breath of fresh air, moving developers out of this highly complex past and into a much more elegant, streamlined present. Which brings us to Section 2, readability and simplicity first, or writing code that makes sense.
This philosophy is absolutely the heartbeat of Python. Its syntax is intentionally designed to be simple, readable, and, get this, it actually reflects the structure of natural language. So the big takeaway here is that when you look at a well-written Python script, it almost reads like regular English. You aren't just deciphering abstract mathematical symbols and brackets all day. You're reading a logical, straightforward flow of instructions. This super easy-to-learn syntax practically obliterated the intimidating barrier to entry that historically kept a lot of brilliant minds out of software development.
But listen, please don't let that beginner-friendly vibe fool you. Python supports multiple highly complex programming paradigms. Whether your specific project needs a functional approach, an object-oriented structure, or just standard procedural programming, Python handles the whole shebang. It is wildly effective and adaptable. You can start with basic commands, sure, but as your skills level up, the language scales right alongside you to handle serious enterprise-level architecture.
Now, what's really interesting about this slide is Section 3, Smart Memory and Processing. Let's look under the hood.
Let's start by breaking down this first concept. Python is an interpreted language. So what does that actually mean for you when you sit down to code? Well, in older languages, you'd usually have to translate the entire program into machine code all at once before it could even run. But in Python, the code is performed line by line. Think of it like reading a set of assembly instructions step by step. If something goes wrong on step 3, the program stops right there and you know exactly where the issue is. This architecture facilitates much quicker development and far easier debugging. Spotting and fixing errors becomes a totally manageable task rather than a massive needle-in-a-haystack headache.
Next up, we have dynamic typing. Now, in older programming languages, if you wanted to store a piece of data, say a number or a string of text, you had to explicitly declare it and manually reserve the computer's memory for it ahead of time. It was a tedious, mind-numbing chore. Python completely tosses that step out the window. The instant a variable is assigned a value, the declaration happens automatically. No explicit memory reservation needed. Honestly, this feature alone has probably saved millions of hours of developers' sanity around the globe. You just type what you need, give it a value, and Python brilliantly handles all the memory management behind the scenes.
All right, let's shift gears to Section 4, the power of community and an ecosystem of tools.
A programming language is ultimately only as good as the people who use it and the tools they build for it. Think of Python's massive standard library not just as a feature, but as an incredibly huge pre-stocked toolbox. Because this library is so extensive, writing code from absolute scratch is far less necessary. Need to process complex data? Parse a specific file format, maybe set up a web server? There are built-in modules and packages ready to go for almost anything you can dream of. It equips you right out of the gate so you can focus your energy on solving your unique problems instead of constantly reinventing the wheel.
And this brilliantly illustrates another real-world advantage, cross-platform compatibility. Whether your team is coding on Windows, Mac OS, or Linux, Python acts like a universal translator. It guarantees that the applications you build are highly portable across incredibly diverse operating systems. You literally write your code once, and it runs virtually anywhere. In today's fast-paced software landscape, that kind of operational flexibility is absolute gold.
All this built-in support naturally results in a remarkably vibrant, sizable community. Every single day, developers worldwide are adding to Python's rich ecosystem of frameworks and libraries. Tools like Django completely dominate web development, while massive libraries like TensorFlow power the intense math behind machine learning. This continuous community effort has genuinely cemented Python as the undeniable backbone for everything, from robust data processing pipelines to the absolute cutting edge of the AI revolution.
Which brings us to our final takeaway, and a provocative question I want to leave you with today. We've seen how Python offers this incredible, almost paradoxical blend. It literally reads like regular English, built entirely on a human-first philosophy, yet it holds the raw underlying power to drive artificial intelligence and massive enterprise systems. It takes the friction out of coding so you can focus purely on creating. So, with a language this accessible and this incredibly powerful right at your fingertips, what will you build? Thank you so much for joining me for this explainer. Keep learning, keep exploring those ideas, and we'll catch you in the next one.